Okay, here we go with the last type of question, and that's a question regarding expected value. So a company estimates that 0.2% of the products will fail after the original warranty period, but within 2 years of the purchase. And they with a replacement cost of $400. So there's an original warranty, and then there's another period of 2 years after that warranty. They think a certain percentage of their products will fail. Not very many, 0.2%. That's 2 out of 1,000, or 1 every 500. And that's not very many, but they don't want the 1 in every 500 customers, they don't want them displeased. So they're going to give them an opportunity to buy a warranty. So a lot of people might buy the warranty, even though their computer or phone or whatever the object is doesn't fail. Right? They don't know if it's going to fail or not, but they just want to feel secure that if it does, that they'll get their money back, that they'll get a $400 replacement cost. So it says they offer a 2-year extended warranty for $41. So that goes beyond the regular warranty and up within that 2-year time period. So they offer 2 years because they think, well, we'll only have to replace at most 0.2% of our products. And so they're going to charge $41 per warranty. So it says, what's the company's expected value of each warranty? So here's how you calculate expected value in general. So generally speaking, expected value which we usually abbreviate as EV, that is equal to the sum of all part values, okay? Part values. And I'll show you what I mean by a part value. A part value comes from the likelihood that something, some money will be exchanged times the value of that money. So we say the likelihood is the probability of an event times the value of that event, that same event. So in the case of expected value, oftentimes we have multiple events. So we have the probability that event number 1 occurs times the value, or that is what the company gains or loses from that event. And then they may have another event. What about event number 2? Oops, I guess I don't need to write all that. The probability of event number 2 times the value of event number 2. And then that could go on and on depending on how many events there are. So we call it up to n events times the value of that last event. So there could be 5 or 6 or 10 or 20 or 100 events. In our case here, there's really only 2 really financial situations where money is exchanged. One is if a person buys the warranty, right? So all people who buy the warranty, every single one of them is going to pay $41. That is 100% of the time a warranty is purchased, they pay $41. Now, some of those people, 0.2% is the expectation, about approximately. So expected value is always kind of an approximation, but it's the best approximation we can make. So we write equals. So the approximation is that every single person, 100% of the time, they're going to pay $41 for that warranty. Okay. But not everybody is going to get that $400 replacement cost. So the company gets $41, that makes it a positive $41, but 0.2% of the time, the probability that it fails, the company loses $400. But now think about that. They take in $41 for every single warranty they sell, all 100% of all their warranties. But only 2 per 1,000 or 1 every 500, they're going to lose $400. So they're going to make a lot of $41, lot of $41 warranties before they have to start paying out. So let's calculate this. 100% of 41 is, of course, 41, plus 0.2% times 400. Now, of course, 0.2%, be careful with this. 0.2% is 0.002. Remember, 0.2% means 0.2 divided by 100. So that has to move the decimal 2 places to the left, so it's 0.002. So make sure you're careful with your calculation there. So that should be 80 cents. 0.002 times 400 should be 80 cents. So they're going to lose 80 cents. So 41 plus 80 is $40.20. So that is, they predict that if they can sell, since they only have to give, they do have to give a lot of money back, 400, but it's so rare that they have to give money back because their product only fails 0.2% of the time. So that would be their expected value. Okay, and that is the end of that video.